9.4, common log ribbons. Common log is a base 10 log, so it would be like log base 10 of 3. You will rarely, if ever, see the 10 actually there. If you don't see a number, this will be written most of the time as just log 3. So if there is not a base number down there, you know that's base 10, that is common log. And that is what the calculator key that everybody wants to use, that's what that log key is common log. So for that problem and a lot of the first section of homework problems, that's all you were doing is hitting the log key on your calculator and finding out what log 3 is. And I think for the most part you're rounding to 4 decimal places. So what is log 3? 0.4771. The biggest challenge to some of you on this set of problems is knowing how to round. Because as far as solving, there's nothing to it except typing it in. So that's what we're talking about with common log. It's a base 10, and you can use your calculator key to solve for that. And we'll use it some throughout this section. Over on page 529, we have 3 to the x equals 11. Some problems that we've seen before, or maybe 4 to the x equals 16. So we asked ourselves what power is 16? And that's obviously the second, so we have x equals 2. So over here, 3 to the what power is 11? Anybody have a guess? Probably not, but maybe. No, you can't figure that out. I don't even know what that is just by looking. So that's what we're learning about in this section, is how to solve that. Could we take both sides of an equation, for instance, this one times 2? For 1 and 2. Yeah. And you add 4 to both sides of an equation. You can do anything as long as you do it to both sides of the equation, right? And so that's what we're doing right now, only we're taking the log of both sides. So it becomes log 3 to the x equals log 11. And then you use your rules. So the goal is what? What we're trying to do here. Get the x by itself. So what's one thing we could do to that x? Using the rules, properties. Move it in front. That's an exponent. We can bring that around front to where we have x log 3 equals log 11. So what's happening between the x and the log 3? It's being multiplied. So what's the inverse operation? So we divide both sides by log 3, and we get our answer. Now, make sure you close. When you push log, it's going to open that parentheses. Make sure you close it before you hit your divide. You got it? 4 decimal places, so we all sounds like we got it. 2.1827. What's 3 squared? So wouldn't you expect 3 to the 11th? Or 3, if you're getting 11, you would expect the x to be just a little bit bigger than 2. 3 squared is 9. Expect that. So you can check to see if your answers are realistic or not. 4 to the x equals 15. So what would we expect this answer to be close to? 2, because 4 squared is 16, but obviously 15 isn't quite 16, so that's not going to be the answer. So we take the log of both sides again. 4 to the x equals log 15. Bring the x around. So we have x log 4 equals log 15. And then what? Divide both sides by log 4. So x is 1.9. Yep. 9534. Over on page 530, we have an inequality. Solve them the same way, just like if it was an equal sign. I will say this example can get a little long and drawn out. So take a deep breath here before we get started. There are several steps here. We have 5 to the 3y. I'm going to make them x's. 5 to the 3x is less than 8. The x minus 1. So we would try to change the bases if we were working a previous section problem. 5 and 8, we would want to change that to something smaller if we could. Is there anything that you could change 5 to? No. You couldn't put in like 2 to the second equals 5 and replace that. So that's why we have the problems in this section that we do. They're not, you can't use the rules and methods that we've used previously. So we take the log of both sides of this one. So we have log 5 to the 3x is less than log 8 to the x minus 1. So similar to we did on the first examples. And what did we do next? Right. Move the exponents in front. So we bring this 3x around. They are still base 10. So we have 3x log 5 is less than x minus 1 log 8. Everybody with me to that point? That's nothing different, again, than the other examples. This next step is a little bit. How many terms is this log 8? How many numbers does that represent? 3. 1. You type log 8 in your calculator, does it give you 3 answers? No, you get 1 answer. Log 8 is one number, just like if you had x minus 1 times 3 out here. And if that was a 3 out here, what would you do? Pretty sure one of you said it, I'm not 100%. Distribute, exactly, and that's what you do here. So you're going to distribute the log 8 into that, just like if it was a 3 or a 4 or any other number out there that you're multiplying. So the left side stays the same, 3x log 5 is less than, if you multiply x and log 8, you get x log 8 minus 1 log 8, and you can put the 1 if you want to, it doesn't matter if you do or not. So again, we're distributing log 8. Again, what's the goal of this problem? Get the x by itself. How many x's do we have here? 2. We have 3x and a 1x. You have to get them on the same side of the equation or inequality. So how would we move them to the same side? Yeah, it doesn't really matter. Just like if you had 2x here, 3x there, and 1x over there, subtract 1 over, and that's what you're going to do. So x log 8, you are subtracting from both sides. And you can't actually do that. So you just write 3x log 5 minus x log 8 is less than negative 1 log 8. And again, what's the goal? Get x by itself. What do these two terms have in common over here on this side? An x. So when something has it in common, what can you do? First step of factoring, we what? Take out a common term, and that's exactly what you're doing here. So we take the x out front, and we open a parentheses, you're basically factoring out an x. So 3x over x would be, sounded like I was subtracting that. We're dividing the x out. We have x over x. What's going to happen? Cancel. So we have 3 log 5 minus log 8. Again, you're taking that x out as well. So how many x's do we have now? Just one, and what's happening between the x and the rest of that stuff in parentheses? What's happening right here? Huh? Multiply. So what do we need to do? Divide. So if you distribute, you're gonna get right back where you were up here, where you had the x's in there. We took the x out. If you distribute it back in, then you're gonna undo the step you just did. So we got the x here by itself. We're gonna divide this stuff out of here. What's that going to leave? The x. So our goal has been accomplished. You do have to be careful typing this in. So I would open a parenthesis before you type anything in. Just open a parenthesis so you can have that whole top stuff, and then close both. So you have two sets on the top, divided by, do the same for the bottom. If you type it in just like that, you can type the whole thing in and get your answer. If you don't, use the right number of parentheses, it will not work. So you should get negative 0.7564. Yeah, one of the other answers in the book was one digit off there in that place too, so that if you're close. Some people would get the top answer, round it, and then divide by the bottom stuff, so your answer would be a little bit different on that. Questions on that? We're going to do one more just like it. I don't know why you would take a number out. That's your goal. You can get the x out by itself. Like you could take a 3x out, but then you have 3, but you end up having to divide by 3. So I just take the x if you got one. It's in common. Let's see. Three to the 2x is greater than or equal to 6 to the x plus 1. What do we do first? Yeah, do the log of both sides. So we have log of 3 to the 2x greater than or equal to log 6dx plus 1. Then what? Bring those exponents around. So we have 2x log 3 greater than or equal to x plus 1 log 6. What do you do next? Distribute that log 6 in. So we have x log 6 plus what? 1 log 6 or just log 6. And we must move the other x log over. And remember, you can't do anything. Don't try to type that in your calculator. That's why you have to get the x's out by themselves so that you can type it in your calculator. So now, take the x out. So we have 2 log 3 minus log 6 greater than or equal to log 6. And the last step, divide that all off of there. So we have x is greater than or equal to, again, careful with your parentheses. We should end up with 4.4190. One more thing in this section. Log base 4 of 25. So what form is that in? Log form, and in order to solve it, we need to turn it into what? Exponential. So when we did this previously, we set it equal to x, and we said 4 to the what power equals 25. Right? And then what do we have to do? We had to take log of both sides. So we had log 4 to the x equals log 25. And then what? Bring the x around. So we had x log 4 equals log 25. And then divide by log 4. And that left us with x equals 2.3219. Anybody look at that problem, see something, you could just jump right to the answer? What?
I mean, jump right to the answer.
Like instead of writing it, going from or logarithmic, writing it in exponential, and then taking the log of both sides. Sure. So in the original problem, looking at log base 4 of 25, we can skip this stuff in there that we changed it to exponential and so on, because look what we're going to eventually type in. You're eventually going to type in log 25 divided by log 4 and get your answer. So we could go from right here and write log 25 divided by log 4. So this number's on top, this number's on the bottom, and get your answer. That makes sense? That's called change of base formula. You can see it there on page 530. Log base A of n. So you can just type in log n over log A. Save you a lot of time. Works for anything. Log base 2 of 12. So what would you change that to? Log 12 over log 2. And what's your answer? 3.585. 5. Way around. What was the next digit? So it becomes 0. Okay. Questions on that? Change base. Homework is 14 through 19. Starts on page 431. Yeah, sorry. Through 19 on that page, and on the next page, 22 through 39.